Hey everyone, Mr. Simone here. The purpose of this video is to go over the real number system and specifically identify what values are part of the real number system. Real number system is broken up into two specific categories, something that is rational and something that is irrational. So what we're going to do is kind of look at our little kind of bubble map here and identify, where do these numbers come from, when have I used them, and what are they? So when you were a little kid, the very first thing that you learned were called your counting numbers or natural numbers. Those are things like starting with 1, 2, 3, 4, 5, so on and so forth. So the natural numbers, when we talk about natural numbers, they are part of your rational amount, okay, which include 1, 2, 3, 4, 5, so on and so forth. All right. Then a little bit later in school, you learned about whole numbers. Now, whole numbers are, in fact, your natural numbers or counting numbers, but they also include one other value. Now, you might have been a little kid and learned about, you have, 5 sandwiches, and Bobby comes and eats your 5 sandwiches. How many sandwiches do you have left? You have 0. So you were introduced to this new idea of 0. 0 is the only thing that separates the whole number from the natural numbers. So whole numbers have 0. They have 1, they have 2, they have 7, they've got 5 billion, they've got all kinds of numbers, anything that you can count up to. A little bit later in your math careers, around 6th or 7th grade, you learn about a new concept of integers. And you're like, well, what are those? Integers are essentially your whole numbers and their opposites. So if you think about a number line learning about integers, you learn that there are positive answers and negative answers. So if we think about it, integers include all values that are whole and their opposites. You might have like -3 or -10. All right, you even have numbers like 4 and even 0. And some people say, well, what's the opposite of 0? Well, 0 is kind of neutral. 0 is neither positive nor negative. So it is something that kind of continues with the integer rules. The last thing to think about is the more general rational realm. Rational, if you think about it, the first part of rational says ratio. So it's really any value that you can represent as a ratio in fraction form. It's a really clever way of thinking of it. All of these examples so far can be represented in fraction form. For example, if I think of 7, I could represent the number 7 as a fraction or in ratio form as 7/1. So what we start to introduce in the larger realm are things like fractions, maybe 1/2, or decimals, like 7/10. Okay? This also includes decimals that terminate or decimals that repeat. You might see something like this where you have 0.45 with a line over it, which means that it goes on infinitely. All right. Other things that you could also see in the rational realm are anything that can be represented in a simpler form, like your integers, whole numbers, and natural numbers. These include things like square roots of perfect squares. So like the square root of 81, which is equal to 9, is in that realm. You can even think about cubes or exponents. We have squares, so something like 3 to the second power. Anything that will simplify to these lower realms is in the rational realm. So these are all values that we kind of consider. For irrational, we do have the most famous irrational that you've used before, which is pi. All right, pi is the value of any circle's circumference divided by its diameter. It's approximately 3.1415, so on and so forth. What makes the difference between rational and irrational is that irrational are decimal values that go on infinitely with no end and no pattern. You can have patterns for rational, you can have terminating decimals, but irrational are values that represent decimals that go on forever and there is no pattern. Things like non-perfect square roots, so square root of something like 29. Again, 29 is not a perfect square. We can't figure out the answer, but you can approximate what it might be. Other examples are decimals shown something like 5.8213 ... All right, where there is no specific pattern and there is no guarantee that there is an end or there is a pattern. So when we start talking about the real number system is made up of rational and irrational. And again, our goal is to be able to kind of identify the difference between the two. Rational, you can represent as ratios in fraction form. Irrational, you can't, all right? You can only approximate or come close if you needed to. There is one other piece that we don't get to, which is imaginary values, which is a later video, and you'll learn that when you get to high school. But hopefully this helps you, and just keep working.